Yeah, thanks for coming. This is a lot of work for me, but it's also fun. I really enjoy it because I can show you what you can do. Because if I can do it, you can do it. So, and you see that?
It's a little bit fuzzy. A lot of light
Oh, that's the light.
Getting better.
Because that's the best I can get it.
Definitely getting
Not too
better.
good, huh?
No, that's way better.
Oh, it's getting better. Okay. This is the drawing. What I do is, the first lecture I gave was on the heart, the second one was on earth, this one is on architecture. So what I always try to do is review it a little bit, even though you didn't take the other lectures. Or if you did, it's sort of a review, because all of these are connected. So this is the moon and the sun and the earth. And the sun and the moon are the same size, okay, on earth. So when we look up at the sun, that's the size of the moon. If we look at the moon, that's the size of the sun on earth. And the center of the earth, the core of the earth, is exactly the same size as the moon and the sun. Now this is just, they have been fighting over the size. The scientists have been fighting over the sizes for a long time. And there's a great variation that they come to. They can't really get to the exact size. So,
The size of the core, you mean?
yeah, the size of the core. They can't really, they have seismic studies, earthquakes and so forth, or they can produce their own seismic. And it goes across, and there are different layers. So when it goes across here, they can measure the time and so forth to find out what size it is, the seismic studies. Well, the problem is that the reason that they can't get exactly the right size is because it's a cube. Okay, and they didn't know that. And so they're finally, in the last month, there's some people in Sweden, some scientists, that have found that it is a cube, and it sits at root 3, which is exactly according to my research, and this is a cube. And I showed last time how that happens and what it looks like when you spin it. So anyway, this has to do with the earth. And the time before I talked about the heart. And the heart also has the configuration of what's in the earth. So if you come to that heart lecture, you'll see that. But I am telling you in the last lecture that the form, this is the form, that's the seven-sided form, and when that form spins, okay, it changes into another form, and if I continue to do the forms, they look like this. And this is the size of the moon, size of the sun, size of the earth, measured it perfectly, seven-sided form fits in there, and right in the middle of the seven-sided form, there is a cube. Can you see the cube in the reflection? Hard to see. But the cube in there is geometrically found. Let me just say one thing. All my work, none of it is based on fantasy. None of it. It's all based on research, science, and measurements. There is no fantasy in here. This is the lack of mysticism. This isn't a mist. I don't have a mist over me. I don't have a veil. Okay? It's right out in the open. And anything that you want to see how I did, I can show you, and it can prove it to you, and so forth. So the cube that's in the center of this form comes through a transformation of forms that I will show you, and it's exactly the size of that circle. So the geometry is showing all of this. And remember, geometry is three-dimensional math. And geometry cannot be measured like mathematics. Mathematics you can measure exactly and get your rulers out and your protractors and everything. But in geometry, you don't need that. All you need is a compass and a straight edge. and a pencil. And those are the 3 geometry tools. That's all you need. No measurements. So it's based on quality, not on quantity. Okay, so this is architecture. I thank you for coming because I didn't know any people would be interested in architecture, but architecture is really what all this work is about because we live in all the time exposed to architecture. We're always in it. Okay, so part of what I talked about last time was root 2 and root 3. So I wanted to show you root 2. This is root 2. This is the number.
You mean the square root of 2?
Yes.
Okay, thank you.
This is the square root of 2. See the number? That number goes beyond 1,000,000, and they still haven't found the end. But I can take the compass and give it to you just like that. So one of the things about, if you look at 10, okay, and if you start with a circle or a form, a triangle, okay, it shows you all the different degrees. But when it gets to 7, look what happens to 7. 7 has a number that it cannot get. All the rest you can figure those out. You can get those with mathematics, but you cannot get that number for 7. It is an esoteric number. It is a number that can't be measured. Okay, so it is the first, like I explained last time, it's the first number that goes into the abyss. You can't hold on to it. So nature has given you a flexibility. There's a real flexibility here in this number. Okay, so where is root 2? Okay, this is 1. This is 1 here. We know that's 1. Okay. This is also the axis of 1. But root 2 is across the edges. So if I draw a square, this is root 2. Don't have to measure it. Gives you exactly this number. Done. So one of the ways I like to show this is that if I put a little water into this cube, it basically will float at 1. Wants to tilt a little bit, but it's basically, I have too much water in it. If I fill it halfway, it floats at root 2. That is root 2. And you see that from where you are? If I take it out, there's the water at root 2. And it floats at root 2. Now if I fill it most of the way up, that's too much, not enough water. It floats, still not much. Huh. It floats at root 3. Now usually it will sink. More water. So what it's showing you is how you can use water to show these roots there. All right, let me, if I hold it up here, how about that? Does that help? So, root 3, it still has a little too much air, but it will go from point to point. So what I'm trying to do is to show you the different ways of what root 2 is and what root 3 is and what 1 is. Because a lot of people, doing my first couple lectures, still don't quite realize what it is. But remember that root 2 divides it exactly in half this way. So if I take this half off and this half off, divides the cube exactly in half. If I go root 3, Okay, it divides it in half three-dimensionally. So, to show you really a nice thing is that if I take a point here, I draw a circle. This is how simple the geometry is. It's not, doesn't have to be complex or anything else. See how I put it right there at the same spot here, the center, but I put it on the periphery, and this time I draw it. Doesn't matter where I draw it, as long as it's the periphery to the center. Every single time, this is root 3. Always. And root 3's can't be measured. You can't measure root 3. Now this is called formative forces. The other one is called regenerative forces. Root 2 is what regenerates. Root 3 is what forms. Okay, this is root 2. Remember, it goes from edge to edge. Now I use an axis. The root 2 is everywhere I turn it. These can be great artistic projects to use this idea. This is root 3. Root 3 goes from all the edges. That's root 3. That's root 3. All the way around. It's always from corner to corner. So it floats like this, completely filled with water. Halfway through the water, it sits like this. And with hardly any water, it's just like this. So to give you an idea of kind of what this is, because all architecture, okay, in the past that's sacred, remember it's sacred because the numbers can't be measured, geometry. The reason it's sacred is because of that number there that you can't measure. So root 2 and root 3 and root 5 have always been used in sacred architecture. Now architecture is all about bringing heaven and earth together. So all the architects have been trying to decide, how can I bring heaven and earth together? Because I want to join those two. I don't want to just be earthbound, but I don't want to be in just heaven also. It's a combination of two of what we have to do here is to bring those together. So let's see what they did in the past. I'm going to draw up here real quick, freehand, the squaring the circle, which is the Egyptians used. I did this last time. What they did is they drew what they call an Egyptian triangle. An Egyptian triangle is 3, 4, and 5. 3, 4, 5, 12. You can measure it, or you can divide it up with a compass, whatever. 3 has always been considered the earth. I'm sorry, the moon. And 4 has always been considered the earth, and 5 is always considered the sun. All throughout, thousands of years, those numbers of what they considered in the Egyptian triangle. Now, so what the Egyptians did is that they made a square here, and since this is the moon, they made the moon here. Then they put the same size triangle over here on this side, which is 5, and this is 3, and this is 4. Then they made a square. Remember, the square is always Earth. Earth is always the square. It's always the cube because it's everything grows up at 90 degrees. When we stand at 90 degrees, all the plants grow up. It has the 4 seasons, has the 4 directions. So 4 was always the big thing for Earth. So what the Egyptians did was they put a circle here, which was the Earth. And then they drew the center of the moon, which is also the sun. You know what I mean? They're the same size. And what they did was they drew another circle here, from here, around, and you can see that doesn't quite. It's just a little bit of this is sticking out on each end. At least it should. And what happens is when they did that, they found out that